vapor pressures of solutions are lower than the vapor pressures of pure solvent. And one experiment that is often performed in grade school to show this is where someone will take two beakers, pour water into each one of them, and then dissolve something into the other one. And then they'll put glass over the top so the system is closed, and they'll just walk away. Later, when they come back, normally this takes a while because things need to be evaporated, but if you leave this out in the sun, eventually all of the water on the left side where there is nothing dissolved in it will end up in the right. And that is because the vapor pressures of solutions are lower than the vapor pressures of the pure solvent. And why that happens is, if I think of a unit volume, the number of water molecules that would be in here for pure solvent is 100%. If I dissolve something in there, then it's lowered. So what happens is that it lowers the escaping tendency of the solvent, which leads to Raoult's law, which helps calculate what the vapor pressure for a solution would be involving a non-volatile thing that's been dissolved in there. What's that? Solute? Yeah, solute. And it goes, the vapor pressure of the solution is equal to the mole fraction of the solvent times the vapor pressure of the solvent. So this is pretty simple. It's kind of like a percent. If I have half of my moles per unit volume that are the solvent, then it takes the vapor pressure down by 50%. If it's 75% solvent, then it's 75% of the vapor pressure. And this last one is for situations involving something that is volatile, so two liquids dissolved into each other. And what I would do is to find the total vapor pressure. I'd find the individual vapor pressures of whatever is in there. If there are three things, then I do three. I do the mole fraction for each one, then I add them all together. So it's pretty simple. And of course, this is for ideal solutions. And an ideal solution is similar to what an ideal gas is, where we're assuming everything runs perfectly. There are no intermolecular reactions or interferences or anything like that.